and welcome to Deeksha Karnataka YouTube channel. Today I am going to give you all formula sheet of all the chapters, and if you want to download the formula sheet you have to join our WhatsApp channel. The link of the formula sheet will be shared in our WhatsApp channel, so don't forget to join the WhatsApp channel. And this is the formula sheet. Obviously it will be available to you for in a downloadable PDF format, so don't forget to join the WhatsApp channel, obviously, as I mentioned before. But I will explain how can you use the formula sheet. Here all the chapters are listed in the order of your textbook, okay, all the chapters. And definitely this formula sheet will not only help you in your PU exam, this will be helpful for your KCET exam as well. Now let's look into one of the chapter, electric charges and field. So if you see in this chapter, what you will get the Coulomb's law. Okay, Coulomb's law and electric field, all the formulas for Coulomb's law, their electric field, the constants, values, etc. Okay, and what you have to do if the medium is changed. Now some of the portions are actually meant for KCET exam, and but the basic formulas and their values are meant for your board exam as well. Okay, so here is the electric field expression. So electric field generally varies as 1 by r square. Okay, force acting on a charge is given by charge into electric field. So everything is explained over here. So Coulomb's law, F is equal to K Q1 Q2 by r square, K is value, epsilon naught's value, and in case of some other medium, this is exclusively for KCET. Maybe I will explain that again before your KCET exam. So you can skip this portion for now, but download the PDF, obviously that will be helpful for your KCET exam as well. And it is a comprehensive formula sheet. Here you will get the dipole moment, electric field for a dipole on this axis, okay, for points on the equatorial plane. All the formulas are listed in this sheet. Also torque acting on a dipole, potential energy of the dipole we generally studied in the second chapter, but dipole is majorly coming on this chapter, so I have included this formula particularly in this chapter as well. Okay, so if you go through this formula sheet, you don't need to go to the next chapter to find only potential due to a dipole. Okay, so here, as I mentioned, all the things are comprehensively mentioned. You can revise the chapters as well from this formula sheet if you are interested, right? Potential due to a dipole is also provided over here. Next is Gauss's law and its applications. So all the applications of Gauss's law are listed over here. Infinitely long, straight, uniformly charged wire. So this is the formula. Now remember, here we have 1 by 4 pi epsilon naught. That's why we have a 2 lambda over here. Okay. So generally in your textbook they give 2 pi epsilon naught and give lambda by r, but 1 by 4 pi epsilon naught is easier to remember, so that's why it is 2 lambda upon r. Field due to a uniformly charged infinitely plane sheet is constant, and it is given by sigma by 2 epsilon naught. Field due to a uniformly charged spherical shell, electric field is 1 by 4 pi epsilon naught q upon r square, and inside the shell electric field is 0. If you plot the graph, you will see that inside the field it is 0 and outside it is decreasing upon 1 by r square. Okay, and let us move on to the next chapter as well. Okay, I will show you the next chapter as well, so that if you have any doubt, that will also be cleared. Okay, so here we have electric potential. What is the definition of potential? Is equals to work done. Potential due to a point charge is given by this. Okay, now potential and potential energy is related by this formula, and you can calculate this due to potential energy. Potential difference is given is equals to potential at that point if you take the starting point to be infinity. So that is the definition of electric potential. So work done required to bring a unit positive test charge from infinity to a point. Okay, that is the definition of electric potential. So that's what I am saying. If you have to be familiar with this formula sheet to get acquainted. So start study from this formula sheet right now. The link will be shared on our WhatsApp channel, so don't forget to join the WhatsApp channel. This is the comparison of electric field and electric potential in a single graph. Okay, due to a spherical shell or spherical conductor. Spherical conductor and shell have identical everything. Electric field inside is 0. Electric field is given by outside is given by q by r square into 1 by 4 pi epsilon naught. Now electric potential due to two charges, potential energy. Okay, potential energy due to two charges is given by 1 by 4 pi epsilon naught q1 q2 by r. These formulas are important from this chapter for specifically for numerical questions. 3 charges are there. If you know 3 charges, generally they will give you equilateral triangle. So if it is equilateral triangle, the distances are generally same. If they are not equilateral triangle, then these distances will be different for the system of charges. Okay, so 1 by 4 pi epsilon naught q1 q2 by r12, q1 q3 by r13, q2 q3 by r23. okay, and electric field and electric potential is related through this formula. X component of electric field is given by minus dV by dx, okay. Now parallel plate capacitor is also there. So capacitance formula, general formula capacitance, okay, here K is the dielectric constant, Q equals to CV. Q is the charge stored in a capacitor, and C into V is the obviously C is the capacitance and V is voltage. Next, series combination where Q is constant, okay. In series combination, remember that charge flowing in the circuit is constant, and correct explanation is this: for two capacitors in series, this is the shortcut formula, may be helpful for solving numericals. Parallel combination is very simple. In parallel combination, voltage is constant no matter you are doing it for resistance or capacitance. These things remain same. Only difference is that instead of Q you can write current I. Now current constant means charge is constant, okay. Current is basically charge divided by time. So if current is constant, charge is also constant. Similarly, for parallel combination, voltage is constant always, and equivalent capacitance is basically addition of the capacitances. Now capacitors of capacitance C in series, so these two expressions are specifically for KCET exam, so you can skip this formula. And energy stored, this can be asked as a 2-marker question as well. What is the energy density or stored in a capacitance? So in that case you have to mention energy stored in a capacitance is U is equal to half epsilon naught E square, okay, and energy stored is half CV square, we all know that, and half Q into V also half Q square by C. So these are all the formulas are listed at one place, okay. And if you want to get all the chapters are over here one by one. Current, electricity, okay, and obviously you will not get this like this, you will get the entire PDF. So don't forget to download the PDF and you can use that to your advantage to score 70 out of 70, right? So as I mentioned, the link will be shared in our WhatsApp channel, and if you have any doubts, any comments regarding the formula sheet or anything else, please don't forget to mention that in the comment below. I'll be back with a new lecture very soon. Till then, bye.